Welcome to today's video. If you're new here, make sure you subscribe. Today we're going to be going through a paper one, and it's going to be the May 2020 paper. Let's get into this. In this question, we're going to be looking at solving inequalities. So the first step is to add 27 to both sides, giving us 7x is less than 35. Next step is to divide both sides by 7. And that gives us x is less than 5. That's it. In this question, we need to express a number as a product of its prime factors. So when I'm breaking these numbers down, I like to start off with the lowest prime factor possible. So we've got 1, 2, 4. The lowest prime is going to be 2. So 1, 2, 4 divided by 2 is going to give us 62. Again, I can use 2. It's going to give us 31. And then at this stage, I think that's it. Yeah, at this stage, that's it. So we just write it out as 2 times 2 times 31, and that's our answer. Or you can put 2 squared times 31. Up to you. In this question, we're going to be looking at ratios, fractions, and percentages. So the first step here is to look at the ratio that we're given. So the number of cars and number of vans is in a ratio of 3 to 7. So we add that 3 and the 7 together to give us 10 parts. And then we're going to do 160 divided by that 10 parts to give us how many vehicles, cars or vans each part represents. So one part is equal to 16. So we know, if I draw a little table here, cars and vans, altogether there are 3 times 16 cars, which are 48. And then the rest are going to be vans. So 7 times 16, that's going to give us 112. Then we look at this next step here. So an eighth of the cars use electricity. So if I do a column there for electricity, an eighth of them use electricity. So we need to do an eighth times by 48. So 48 divided by 8, which gives us 6. So 6 cars use electricity. 25% of the cars use diesel, so I'm going to do another column there. So we're going to do 48 divided by 4, because that will give us 25% or a quarter, and that is 12. And then it says the rest of the cars use petrol. So to work that out, we're just going to do 48 minus the electric and diesel cars, so minus 6 minus 12, so that's 48 minus 18. In this question, we're going to be looking at standard form. In the first part, part A, we need to change that standard form to an ordinary number. So 1.63 times 10 to the power of minus 3, that's just going to move your decimal 3 places to the left. So we'll end up with 0.00163. Okay. Part B. Part B, we need to change this ordinary number into standard form. So you need to remember that with standard form, the first part needs to be between 1 and 10. So we're going to put our decimal in between the 4 and the 3. So we get 4.38, and we need to times it by 10 to the power of how many jumps there are. So 1, 2, 3, 4, 5. 5 jumps to make it this ordinary number. So 10 to the power of 5. So in part C, we start off by timesing these numbers on the left together. So 4 times 6, giving us 24. And then we move on and times the 10 to the power of 3 and the 10 to the power of minus 5. And when multiplying these out, we add the indices together. So we get minus 2, 10 to the minus 2. If you look here, we've got a 24. So that means it's not quite in standard form. As I said at the beginning, it needs to be in between 1 and 10. So we make that 2.4. And we do that by dividing this side by 10. Which means we need to times this side by 10 to keep the number the same. So we end up adding an indice to this one, making it 10 to the minus 1, and that's our final answer. In this question, we're looking at angles in polygons. So we can see we have a hexagon on the left here and a pentagon on the right, and the question's asking us to find this angle X. So if we are to split this shape into two like that, and I'm going to call this angle X and this angle Y. Angle X is the external angle of our hexagon, and angle Y is the external angle of our pentagon. The formula to work out external angles is 360 divided by the number of sides. And so to work out X, we're going to do 360 divided by 6, which is going to give us 60 degrees. And then for the shape on the right, the pentagon, we're going to do 360 divided by 5, which gives us 72 degrees. And then we add together 60 degrees and 72 degrees to find the original X value that they asked for. And that gives us 132 degrees. In this question, we're going to be looking at quadratics. So the first thing we need to do is complete this table above. To do that, we need to sub our X value into the equation up here in order to get the Y values that are missing. So if we were to sub minus 1 into this equation, we'd get 5 for the value of Y. If we were to sub 2 in, we'd get minus 1 again, and here we'd get 1, and if we sub 4 in, we get 5. Part B, we need to draw this graph on this grid below. So we start at minus 1, go to 5, 0, we go to 1, 1 we go to minus 1, minus 1 again, 3 we go to 1, and at 4 we go to 5. And then we're going to join these lines up with a curve. So we go down like this, go slightly past those 2 points and join it up there. Part C wants us to find estimates for the solution to this equation here. If you notice, this equation is the same as this equation above, except y now equals 0. So we find the line where y equals 0, which is just the x-axis, and we see where that line crosses the graph. So it crosses the graph, the curve that we drew at these 2 points here. And we're going to read the x values from the graph. So this x value here is going to be roughly 0.5. And the x value here is going to be about 2.5. And there'll be our 2 answers for part C. In this question, we're going to be looking at density, mass, and volume. So we've got 2 cubes here. We're given the mass, but we need to work out the density of cube A and the density of cube B in terms of their ratio. Okay, so to work out the density of cube A, we're going to use the formula. Let's write out our triangle first. So we've got density there, mass at the top, and volume there. So I'm assuming you know how to use the triangle. But first of all, cube A, let's put it over there, cube B over here. Let's work out the volume. So the volume of cube A is going to be 3 cubed, which equals 27. Volume of B is going to be 4. It's going to be 4 cubed, and that equals 64. Let me just put the units in. Next, we're going to work out the density, because now we have the volume and we have the mass. So density equals mass divided by volume. So for cube A, it's going to be 81 divided by 27. Sorry, 27. We get 3. And we do the same over here for cube B. So our mass is 128. And we're going to divide that by our volume, which is 64. And that gives us 2. So the ratio is just going to be 3 to 2. In this question, we're going to be calculating the mean from a frequency table. So the first step, you can see we've got our class widths here. So we're going to get our midpoint. That's going to be the first thing. We want another column for our midpoint. So we're going to put 5 here, 15, 25, 35, and 45. Then we need another column for our midpoint multiplied by the frequency. So 8 times 5, it's going to give us 40. We're going to get 150 here. 7 times 25, we're going to get 175. Then we get 70, and then we're going to get 135. At this stage, we need to find the sum of this column, the midpoint times frequency. Once we sum that, we're going to get 570. Next thing to do is get the sum of our frequency, which we know is 30 because it says 30 days. And then to solve this, we're going to get the sum of the midpoint times frequency and divide that by the sum of the frequencies. So we're going to get 570 divided by 30. We can simplify that a little bit. And then our final answer is 19. So 19 centimeters. Now we're going to be looking at surface area. So we need to find the surface area of this shape. The tricky part of this is finding the area of the top of that bottom cube, if you see what I mean. So we're going to have to find the area of that, the top of that cube, and minus the area of the base of the cube on top, if that makes sense, to find that surface area. So the first step is to find, let's find the volume, so not the volume, sorry. Let's find the surface area of the cube apart from the bottom. So there's going to be 5 faces that we can see. So one face would be 4 times 4, so 4 squared, but there's 5 of those, so that'll be our total surface area for the top cube. So top cube. And then let's look at the bottom cube now. Actually, before we move on, let's solve this, see what that is. So 4 squared is 16 times by 5, that's going to give us 80. So 80 centimeters squared. So the bottom cube. Let's look at the sides. The sides on left and right, that's going to be 5 times 6. 5 times 6, but there's 2 of those. So we times that by 2. And that's going to give us 60. Then we're going to look at the front and the back. The front and the back, that's going to be 7 times 5 times by 2 again. So 7 times 5 is 35 times by 2, 70 centimeters squared. And then we're going to get the bottom. So that bottom bit is going to be 7 times 6, which is 42 centimeters squared. And remember on the top that I mentioned at the beginning, the top, we're going to find the top of the bottom cube and minus the bottom of the top cube. So that is going to give us a top minus bottom of top cube. Bit confusing, but I'm sure you understand. So then that's going to be 7 times 5, but we need to minus the face of the cube, so we're going to minus 16 from that. And once we've done all of that, it's going to be 42 minus 16, which gives us 26 centimeters squared. And then lastly, we've worked out all the surface areas. We just need to add these 5 values up, and once we add them up, we will get 278 centimeters squared. And that's our final answer. Cumulative frequency tables. So this first part of the question, we need to complete the table. So we start with 10 for this class width. Then we add the 15 on, giving us 25, add the 25, giving us 50, add the 30, give us 80, add that 5, 85, add the 15, and we're at 100, which makes sense because there's 100 days. Let's see what part B is. So part B is to represent the information on a grid. So what we're going to do is look at the first bit we've got. We've got 0 to 50 as a cumulative frequency of 10. So at 50, we're going to plot 10. So we go to 50 along the profit and then go up to 10. and we just place a cross there. Next one, at 100, we're going to plot 25. So let's go to 100, and 25 is going to be here. So just be careful when reading the y-axis. At 150, we're going to get 50. At 200, we get 80. At 250, I think it was 85. And at 300, we get 100, as you can see there. Next thing to do is join our line, join up our points, like so. And that's our cumulative frequency graph drawn. The next part of our question, part C, use your graph to find the estimate for the number of days on which the profit was less than 125. Okay, so we're going to go to 125 on the profit on the x-axis. So go to 125. Let me just change the color of the pen. 125, which is going to be in between 100 and 150. We see where it meets the line, and then we go across. We go across to the y-axis. So it should meet it around there. Yeah, so for that part, we're going to get 40. Or maybe if I lower it, I think I've drawn that line a bit high. Let's bring that down a bit so it actually meets. Yeah, so that's going to be, because these boxes represent 2, that's going to be 38. So 38 days. And then it says use your graph to find an estimate of the interquartile range. So for this bit, you need to know that your interquartile range is the upper quartile minus the lower quartile. So to find the upper and lower quartile on this graph, we need to look at our cumulative frequency, and our upper quartile is going to be 3/4 of our cumulative frequency, which is at 100. So 3/4 of that is going to be 75. So we need to go to 75 on the cumulative frequency on the y-axis. So let me just draw a line there. I think change the color again to green. Okay, cool. So 75, that's going to be here. Meets our line there. Do we need to draw another line? So we draw a straight line down to the x-axis. That looks like we've got 160, 70, 80, 90. That looks like 190 for our upper quartile. So let's write that down, 190. And that's our upper quartile. The lower quartile is going to be 1/4 of 100 in our cumulative frequency. So that's going to be at 25. So let's go to 25. Go across to our point again. And then we go down. That looks like it's at 100. So for that one, I would say our lower quartile is 100. So remember, upper quartile minus lower quartile is our interquartile range. So 190 minus 100 gives us 90. So our interquartile range is 90. Ratios. So in this question, we have a bag of sweets split up into lime flavor, strawberry flavor, and orange flavor. However, for the ratio, we don't know how many orange sweets there would be, and that's what we need to work out. But we have a bit of information here. We know that Cormac is going to take a sweet from the bag, and that probability that he takes a lime flavored sweet is 3/7. So we can form an equation out of this. We know 3/7 of the total is going to give us 9. Yep, because there's 9 there. Let's create our equation. So 3/7 times t total equals 9. We're going to rearrange this by times in both sides by 7. That's going to give us 3t equals 63. Then we're going to divide both sides by 3, giving us 21. So that means there are 21 parts altogether. And because there are 21 parts altogether, we can work out x now. So we can do 21 minus 9 minus 4. So that's 21 minus 13. And that leaves us with 8. So x equals 8. Reoccurring decimals to fractions. So in this question, we start off by making x equal to the value we've been given. The second step is to get these reoccurring numbers on the right side of the decimal, but like just on the right side of the decimal with no numbers in between. So we need to times it by 10. So you'll see what that does. If I times it by both sides by 10, it becomes 10x, and that equals 1.17 recurring. So now we've got the recurring part on the right side of the decimal with no numbers in between. We need to get it on the left side of the decimal, and to do that we're going to times it by 100 because we need to move two numbers. So we times both sides by 100. That's going to give us 1000x equals 117.17 recurring. And as you can see, now that we've got two of these with our recurring 17, we can minus it to get rid of that recurring part. So what we're going to do is this line minus this line. So 1 minus 2. So 1000x minus 10x gives us 990x. And 117.17 recurring minus 1.17 recurring gives us 116. The next step to find x and our fraction is to divide both sides by 990, which gives us 116 over 990. And we can leave it like that, no need to simplify. Speed time graph. So we have our graph here, and it says work out an estimate for the gradient of the graph at t equals 2. So t equals 2 at this point here. So we need to, first of all, draw a straight line that touches that t equals 2 and follows the shape of the graph like that. Next step is to find the gradient of that line that we've just drawn. So I can see it goes through this point here, which is 1, 2. And we find another nice point, and it goes through this one there. So that is going to be 5. It would be 5 and then 5.4. So to find the gradient, I'm going to use the following formula. Gradient equals change in y, which is our y2 minus our y1, then our x2 minus our x1. So our first coordinate is going to be this one over here. That's going to be our x1, our y1, that's going to be our x2, and our y2. So if I just put these into the formula now, I get gradient equals 5.4 minus 2 over 5 minus 1. That gives me 3.4 divided by 4, and so with that you'd set up a division. So 4 divided by 3.4. So it doesn't go into the 3. How many times does it go into 34? 8 times. So it goes in 8 times, remainder 2, so we can add a 0 there. Sorry, let's put 0. How many times does it go into 20? It goes into it 5 times. So our gradient is going to equal 0.85. We have a part B here. It says, what does the area under the graph represent? So what does all of this area here represent? And the answer to that is it represents the distance travelled. Yeah, so we just say it represents the distance traveled. And that's everything. Vectors. So part A, we need to prove that A, B, and C lie on a straight line. So we need to take a look at their gradients. So AB is equal to 3A plus 4B. And then AC is equal to 15A plus 20B. Let's factorize AC. So factorize out of 5. And that leaves us with 3A plus 4B. Looking very similar to AB, but 5 times bigger. So AC is 5 times bigger than AB, but it goes in the same direction. So same direction, but 5 times bigger. So that's part A proven. Let's go on to B. So D, E, and F are 3 points in a straight line such that the following vectors, and they've mixed ratio into this. So we need to find the ratio of length of DF to the length of DE. So we know DF is going to be our DE plus EF. So let's write that in. So DF, our DE is 3E plus 6F minus 10.5E minus 21F. That gives us minus 7.5E minus 15F. So at this point we're going to factor out minus 7.5, which gives us E plus 2F inside the brackets. Then we're going to look at our vector for DE. So DE is 3E plus 6F. And if we factorize out of 3, we get E plus 2F on the inside. So when looking at the ratios, you can see that's on the scale of 3 times that direction. This is on a minus 7 times that direction, 7.5. But as lengths can't be negative, we're going to make that a positive 7.5 to the ratio of 3. Tree diagrams. This question says a first aid test has 2 parts, a theory test and a practical test. The probability of passing the theory test is 0.75. So that gives us a hint for the first bit. Start drawing our tree diagram. So this is our theory test. That's our theory. This is going to be the practical. So theory on passing that. So I'm going to put pass. They've told us that is 0.75. And as you should know, branches need to add up to 1. So if it adds up to 1, then this is 0.25 for a fail. And then we can make our other branches over here for our practical. So same thing, pass and fail. Pass and fail. However, on this line, it says the probability of passing only one of your 2 parts is 0.36. So that doesn't actually tell us how to fill out these branches for our practical. Instead, we have to create an equation. So what I'm going to put there is that our chances of passing is going to be X. We don't know it. But what we do know is our branches need to add up to 1. So if passing is X, to fail would be 1 minus X. And the same for this one. And the same for that one. So that's how we set it up initially. We know that the 2 events are independent. And the probability of passing only one of the parts is 0.36. So that could be a pass and a fail, or a fail and a pass. So I'm going to highlight these branches. So this could be one route. You could pass and then fail, or you could fail and then pass in order to satisfy what this question is saying. So when we go along the branches, we times, and at the end we're going to total them up and see, and that should be equal to 0.36, and then we'll be able to create an equation to find the value of x. Okay, so what we're going to do is 0.75, we're going to times along the branches, 0.75 multiplied by 1 minus x, that will give us our value here, and then we're going to do 0.25 times x, and that would give us a value there, and then we'd add those together. So 0.25 times by x is just that, and when we add them together, that should equal 0.36. So now it's just a case of rearranging the equation to find x. So we're going to get 0.75 minus 0.75x plus 0.25x equals 0.36 after expanding that bracket. Then I'm going to collect my like terms, as you can see here. 0.75, that's going to be minus 0.5x equals 0.36. And then I'm going to bring the 0.36 over to the left and move that x to the right. So that's going to be 0.39, sorry, 0.39. That's going to be equal to a positive 0.5x. So I'm adding that to both sides at the same time. And so x is going to equal 0.39 divided by 0.5, which is 0.78. The final line of this question says to work out the probability of passing the practical test. Well, we know that the passing the practical test, we labeled it as x. We found x, which is 0.78. So that's going to be our answer. And that's the question finished. Direct and inverse proportion. So you should know the equations for this question. And we're going to look at the first two lines initially. So y is directly proportional to the square root of t. So if y is directly proportional, we're going to do y equals k, and that's to the square root of t. So it's going to be like that. Next part, t is inversely proportional to the cube of x. So that's going to be k over the cube of x. Like so. Then it says find the formula for y in terms of x, give it in your simplest form. Okay, so we're going to use these values that we have been given, our yt and our tx, to find k, and then we'll work from there. So for the first bit, if y is 15 and t is 9, we need to find k. So first of all, let's root the 9, giving us 3, and then we're going to divide both sides by 3, and that's going to give us 5, so k equals 5. And if we write that out again in its original form, that's going to be y equals 5 root t. Now let's work on this one. So if t equals 8 and x equals 2, 2 to the power 3, 8 equals k over 8, k equals 64. And if we sub that back into the original equation, we've got t equals 64 over root x cubed. Okay, perfect. Now we have to give a formula for y in terms of x. So we have what y equals over here. However, they want it in terms of x. And as you can see here, we have what t equals. So we can just sub t into this equation here. And that's what we're going to do. So y equals 5 root 64 over x cubed. And then we're able to root the 64. So we're going to make that 8 on the top. But we're not able to root this cubed bit, so we leave it like that. And then we're going to times 5 by this fraction, and that gives us 40 over root 3 over root x to the power 3, sorry. And that's its simplest form. We leave it like that. We have an indice question to look at now. You can see the question, we just need to work out the value of what we've been given. I'm going to change the fractions in the brackets to improper fractions. So 5 times 9, 45, plus the 4, 49 over 9. Put that in brackets, and it's to the power of minus a half, times by 14 over 3. Might as well put it in brackets. And that's over 2 to the minus 3. Next, we need to understand how to use the indices to simplify this. The minus is going to flip the fraction. The number on the bottom is going to be what we're rooting it to. The number on the top is what we're raising it to the power of. So in this case, we flip this, making it 9 over... Let me just do that first. So we flip that using the minus, gives us 9 over 49, and we're still left with the half. We'll come back to that. That half is going to square root it. So we are going to have 3 over 7 times 14 over 3. And that's all over 2 to the minus 3. I'm going to start working on this side. Let's multiply these out. Actually, we can cancel these down. So make that 1 and 1 there. So 1 times 14 is going to give us 14. And 7 times 1 just gives us 7 there. Still over 2 to the minus 3. So on the top, we have 2. That's 2 over minus 2 to the minus 3. 2 to the minus 3. Remember that flips it, so that becomes 1 over 2 to the power 3. So now that's 2 over 1 over 2 to the power 3. If we times a half by itself 3 times, we get 1 over 8. And so we now have 2 divided by an eighth, which is 16. And that's the final answer. Algebraic fractions. So in this question, we need to add these algebraic fractions here. We need to leave it in the form you can see there, which looks similar to the quadratic formula. So I'm assuming we're going to have to use the quadratic formula at some point in this question. So first step is to times the left fraction by this denominator and times the right fraction by this denominator. So I'll show you how that works. We end up with 1 times x minus 1. Close the bracket. And then we get 3 times 2x minus 1. And we times the bottom denominators together. So 2x minus 1, x minus 1, like that. So on the top, let's just expand that out. Times it by 1, that's just going to be x minus 1 plus 6x minus 3. And that's going to be equal to this denominator times by 1, which is just it how it is. Okay. Collect our like terms on the left. So we have 7x minus 4. We can expand these brackets here, so that gives us 2x squared minus 2x minus x plus 1. Collect the like terms again on the right side. 2x minus 3x, x squared, plus 1. Let's make this equal to 0 so we can actually solve the quadratic. So we've got 2x squared minus in the 7x, so minus 10x. Add a 4, so that's 5. Okay, so at this stage we have a quadratic that we need to be able to solve. To solve this, we're going to use the quadratic formula just because of the form that they want it in. So you should know that the quadratic formula is, let me write it over here. So it's minus b plus minus the root of b squared minus 4ac over 2a. Right, so, and in this question, our values for a, so our value for a is here, 2. Value for b is minus 10. Our value for c is 5. So let's put that in the equation. Minus b, so that's going to end up being a positive 10. Minus times a minus once we plug it in. So 10 plus minus the root of b squared. So that's going to end up being 100, 10 squared, minus 4 times a times c, all over 2 times a, which is 2 times 2, and that's 4. Let's simplify this a bit and see what we get. So 10 plus minus, so 100. So what is the minus 4 times 2 gives us minus 8. Minus 8 times 5 gives us minus 40. Okay, over 4 again. 10 plus minus, let's make that 60. So we've got that at the moment. Okay, so if you're familiar with surds, we are able to simplify that root 60 a bit more. So I'm going to start writing over here. Plus minus. So that 60 can be, it needs to be broken down into a number that can be rooted, which is 4. So it can be broken down into 4 and 15, because 4 times 15 gives us root 60. That's still over 4. So again, we got 10 plus minus, that gives us 2 root 15 over 4, as you can see. And then we can just divide everything by 2. So when I say everything by 2, we divide that by 2, that by 2, and that by 2. And what that does is it gives us our simplified answer. It's 5 plus minus root 15 over 2. And now that looks like the form that they wanted. In this question, we're looking at straight lines, tangents, and gradients, perpendicular gradients. So it says the center of a circle is the point with the coordinates minus 1, 3. Point A with the coordinates 6, 8 lie on a circle. We need to find an equation of the tangent to the circle at A and give it in the following form. So first of all, let me just draw out a circle to make this look, to allow you to visualize it a bit better. There we go. It's told us the center of the circle, and the center of the circle is with these coordinates. Okay, cool. So minus 1, 3, that's for the center. And then somewhere over here is point A, which is 6, 8. And we need to find the tangent. So first of all, let's draw the radius in, because the center to the point on the circle is going to be the radius. I haven't drawn it the best, but it will do. We need to find the tangent. Let me just draw a tangent. So there, that's a tangent. And something to remember is that the tangent meets the radius at 90 degrees, so you should know that. Okay. Okay, so first step is working out the gradient of the radius, and we do that by looking at these two coordinates that we have. And the formula for working out the gradient is gradient, which is m, is our y2 minus y1 over our x2 minus our x1. So basically changing y over changing x. So let's have a go at doing that, putting the values in. This is our x1, by the way. That's our y1. That's our x2, sorry, and our y2. Let's sub those in. So it's 8 minus 3 gives us 5. 6 minus 1 gives us 7. So 5 over 7 is our gradient for the radius. But for the tangent meets the line, the radius, at 90 degrees, so it's perpendicular. So we need to find the perpendicular gradient. So to find the perpendicular gradient, what happens is there are 2 steps. First step is to flip the gradient, and then the next step is to change the sign. So we flip that gradient, making it 7 over 5. Second step is to change the sign, so it's currently positive. We're going to make that a negative. So negative 7 over 5. Okay, next we're going to look at the equation of a straight line. So y equals mx plus c. So this is for the tangent. We're now working out the tangent. And we've just worked out the perpendicular gradient, so that belongs to the tangent. So I'm going to write that in. This is the tangent gradient that we've worked out. The next step is to find C for the equation of the tangent. So because we already know a coordinate that lies on our tangent, we're going to use that, sub it in, and find C. So y is 8. Gradient is still our perpendicular gradient. X is 6. And we've got plus C. Let's times this out. So minus 7 times by 6 is minus 42, and that's over 5 plus C. Okay, and let's rearrange this. So let's times everything by 5 to get rid of that 5 underneath there. So we end up with 40 equals minus 42 plus 5C. Then we have to move the 42 to the other side, so that becomes 82 once we've added it, equals 5C. We've got to divide that now by 5. So it's going to give us, so C equals 82 over 5. And then next step is to put that back into the formula. So we're going to put that back into here. I'm going to start writing over here. So that means y equals minus 7 over 5 x plus 82 over 5 for C. We can still simplify this a bit, so we're going to times everything by 5 to simplify it. So that gives us 5y equals minus 7x plus 82. Remember in the question at the last line it says it wants it in that form there, so we're going to put it in that form by bringing these two values to the left. So we'll end up with 7x, it becomes positive, plus 5y minus 82, and that's equal to 0. And that's in the form that we needed it in. So that's the question complete. Shaded regions in circles. So this is a final question on a past paper, so it's not going to be easy. They've told us the radius of each of these 3 circles is 4, and we need to find the area of these 2 shaded regions in terms of pi. So let's go with that first bit of information that they gave us. We know that the radius is 4 centimeters. So we'll start on this side. That's the radius of both the left circle and the middle circle. This here is the radius of the left circle.
Which phone number? Contact the device you need to call.
And this radius here is the radius of the center circle. So as you can see here, I've created a triangle using this information that we have, which means that each of these lengths are 4, meaning we have an equilateral triangle. So all of these angles are 60. And that's going to be the same around the circle if I was to complete it with triangles. Like so. So we would have 6 triangles in that center circle, all with lengths 4 and angles of 60, sorry. So what we are going to do in this question is we're going to find the area of a sector and then find the area of a triangle, one of these equilateral triangles, minus it from the area of the sector. So we're left with that little segment there. Once we've found the area of that segment, we know that there are 2 of them in this part here, so 2 of these segments, and we're going to minus that from the area of the sector, leaving us with the shaded bit, and then we times that by 2 because there's 2 of them. So I know that seems a bit confusing, but let's get into it. So the first thing to do is work out the area of the sector. So sector, that's going to be 60, the angle 60 there, 60 over 360 times by pi r squared. Radius is 4 squared. So simplify that, that's a sixth, times pi times 16. And then, yeah, so at this bit we get 16 over 6 pi. We can simplify that a bit to 8 over 3 pi. And that's the area of the sector. Next we're going to work out the area of the triangle. So the triangle is we're going to use half AB sine C to work out the area of the triangle. Half times 4 times 4 sine 60. 60 is our angle. Something to note, this is not a calculator paper. You need to know your exact trig values. So your value for sine 60 is going to be √3 over 2. So let's put this back in. This ends up being 8 √3 over 2, which can be simplified to 4 √3. So that's the area of the triangle. Next bit, like I mentioned earlier, we're finding the area of that segment now by doing the area of the sector minus the triangle. So the segment is sector minus 4 √3. So that's the area of the segment. Next bit is to work out the shaded area. So shaded area, that's going to be the area of this sector, so 8 over 3 pi minus 2 of the segments. So minus 2. Oh, I've got to write all of this out again. So 8 over 3, sorry. We write it out again, a bit messy. Minus 8 over 3 pi minus 4 √3. So that's going to give us one of the shaded areas. But because there's 2 of them, we have to times that whole thing by 2. Let me just put a line underneath this and continue underneath. Let's expand that bigger bracket first. So 2 times 8 over 3 pi, that gives us 16 over 3 pi minus 4, and then we'll leave that bracket as it is and come back to expanding it in a second. Okay. So now let's expand this bracket. Minus 4 times 8, it gives us minus 32, and still over 3 pi. Minus 4 times minus 4 √3, that gives us a positive, that's 16 √3. Okay, so at this stage here, we need to, don't know why I wrote 13 there. At this stage here, we need to minus these. So that's going to give us minus 16 over 3 pi plus 16 √3.